Alright, let's look at the homework 4.7, problem number 8. Alright, so this is the gutter problem, and we have, let's see, the material which has a 30 centimeter width, and we lift up the 1/3 on both ends to create a gutter, alright, which is shown here. And we want to find the theta, the angle, so that this is going to have the maximum capacity. Right, so let's do that. Right, so in order to have a maximum capacity, we just have to make sure that it has the maximum cross-sectional area. So we just need to maximize this area right here. Right, so let's call that A. Right. So in order to find the area, so area formula for trapezoid is 1/2 top base plus bottom base, right, times height h. Right. So if you want to come up with a height h, we can probably do this. Visualize right triangle right here. Right. And since this is 10 right here, right, so it's if you multiply by sine, you're gonna get this length here. So 10 times sine of theta, right, and 10 times cosine will give you this length here. So it's a 10 cosine of theta, right. So this length, this is going to be our height. H is going to be 10 sine theta, right? So if you split this into the top side, so this is going to be 10 cosine of theta, right? This is just a rectangle, so that's 10 there. And then this is another 10 cosine theta, right? So following the formula, so we have 1/2. Right, so top side is going to be, you have 10 and also 20 cosine theta, so you have two of these guys, and plus bottom one is 10, so 10 here, and height is 10 times sine theta. Alright, so that's the function. So let's try to simplify. So it's going to be, right, so 2, I'm going to just cancel 2. So I'm going to distribute 1/2 to 10 and 20 cosine, and also 10. So you have a 5 from here, 5 from there, so that's 10. So you have, and this is going to be 10 cosine of theta. So I'm going to pull out the 10 from here, and also 10 from there. Then you're going to get, let's see, so that would have been 10, so pull out, so it's going to be 1, 10 cosine, so this is going to be plus cosine of theta, right? Then you have a sine of theta here, right? So just simplify, you get that. Alright, then we can just take the derivative. So let's find the derivative of area with respect to theta, right? So 100 is just a number, so put that there. Right, I'm going to use a product rule. So derivative of this guy, derivative of 1 is 0. Derivative of cosine is negative sine of theta times another sine of theta. So I'm going to just put squared plus quantity 1 plus cosine of theta. So that's just the first guy. Multiply by derivative of sine, which is cosine of theta. Alright, so using a trig identity, we can rewrite sine squared as 1 minus cosine squared of theta. So I'm going to put that in. Then you're going to get 100 is still there. Right? So this is going to be, let's say, negative, so cosine squared. And maybe I'll just do that. Let's see, -1, so it's a -1 plus cosine squared of theta. Right? Then you have another cosine, so I'm going to distribute cosine of theta to 1, and the cosine, we get cosine of theta plus cosine times cosine is cosine squared of theta. Alright, and collecting the like terms, we have 100. Then you have two of these guys, so 2 cosine squared of theta plus cosine of theta. Then you have minus 1. Right, so I can probably use the parentheses there. Alright. Alright. Then we want to set that equal to 0, but before that, luckily we can factor this out. So 100, and you have a 2 cosine of theta, and then you have a cosine of theta, so that we can create 2 cosine squared. Then I would say plus 1 here and a minus 1 there. Multiply these guys, negative 1, 2 times 1 plus negative 1 times 1 is going to give you positive 1. So that will work out, right? So we set this guy equal to 0. Alright, so there are a couple possibilities. Alright, we can make this guy equal to 0, which means that the cosine has to be 1/2. So cosine of theta equals 1/2. Another possibility is we can make this guy equal to 0, right? So that would be cosine of theta is equal to negative 1. Alright, so let's look at the unit circle. Alright, so here x-axis, here is the y-axis, origin, and this is a unit circle. Right? Remember that the cosine represents the x-coordinate of the point, so from here we want it to be 1/2. So 1/2 is right here, and there are a couple points that we can think of. Alright, so here's the point here and point there. So angle here would be, so this is 1/2, and this is square root of 3 over 2, and this is 1. So angle here is 60 degrees, right, which is pi over 3, right? And we can think of another one, but you can see that this is going to be way too big, right? Because it's going to actually exceed 180, so we don't want that. So only thing that's you can still write that down. So theta is going to be pi over 3, and then this is going to be 1, 2, 3, 4, 5 pi over 3. All right. But you can see that the one you're looking for is this angle. Alright, and this one, when x value is -1, so the only point that has -1 as the x-coordinate is there. Alright, then the angle here is obviously 180, which is pi. But you can see that that wouldn't be a good idea because that will fold everything over. So the capacity is going to be 0. So we know that the angle would be pi over 3. So let's type that in. We have pi over 3. Alright, let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.